exam.
Yeah, do you have an AP exam?
Yeah.
Okay, so first of all, a big misconception is that radians always has pi in it. It doesn't. They do on both worksheets I just handed you, probably on your homework. They quite often have pi in it, okay? But I guess that would be like saying an angle always has like a 30-degree reference angle. I could have the sine of 37 degrees, okay? And I don't know what that is myself. I know it must be a little bit between 1/2 and square root of 2 over 2, just because I know it's between 30 and 45. But people out there in the real world have to know the sign of inconvenient angles, even with decimals, quite often, okay? But the thing is quite often they also have to add up and multiply treacherous numbers, and but they're going to look pretty silly if they don't know, like 6 times 3 is 18. So if you don't know sine of 30 is 1/2 and cosine of 45 square root of 2 over 2, those are very common. You should know those off the top of your head when you go into calculus or a similar class, okay? So that's what I'm trying to get you to do. Nobody's going to fault you for having to get out a calculator and punch in sine of 37 degrees, because I don't know what it is either, okay? And so what you're learning is common angles. I could have the sine of 1.143 degrees. I'd have to be in degree mode in my calculator. It could be a very tiny, tiny angle. It would be hard for me to draw a 1 degree angle, if you think about it for a minute, around 360 degrees. But there are certain people that have to move something 1 degree in the military, something that's very, very, very far away, and they need to know like where this placement is and this placement is, or you could, in outer space, 1 degree might be hundreds of miles apart. Do y'all see what I mean? Even though the edge of, like if this is the edge of the earth, whereas this is our classroom, whereas this is in outer space, do you see this little teeny tiny angle? What you're looking at, if you're 1 degree off, could be catastrophic.
Yeah.
Okay? If you're trying to land somewhere, you could just totally miss it. It's real important in things that, like if you're flying somewhere, unfortunately if you're shooting a missile at someone, or something like that, you don't want to be off by a degree and go, sorry, didn't mean to blow up your house. So,
Mom always tells me that when I make like silly mistakes.
It could be
It's like you just
catastrophic.
killed the ship.
Yeah, really, yeah. It can be catastrophic, so we need to be precise. Now, if I write this, sine of 1.143, that is not the same question. What do you notice is missing there? The degree symbol. That means I'm in radians. The absence of a degree is in radians, okay? There's not really a mark for radians. So if I have the sine of 3.14, why is that in radians? Only because it doesn't have the degree circle, okay? What if I do this? Now I'm in degrees, right?
Yeah.
You kind of feel like you're in radians because it's got the pi in it, but that's just 3.14 degrees. This is 3.14 radians, okay? Like inches are way bigger than their conversion centimeters. There's a pretty big difference in a mile and a kilometer in conversions. I had a friend that just ran yesterday a 60K in the park, and that came out to 37 point something miles.
What?
The 60K race in the park. One of the coaches of the team I run for ran the 60K. I've had a few friends that have run it. The hardest part to me would be doing like 7 laps of Central Park. The most I've ever done is 4 or 5. But by the time you don't even remember what your name is after that. But anyway, do y'all see what I mean? Like there's such a big discrepancy. It'd be hard. You wouldn't want somebody to say I ran 60. And they mean miles instead of kilometers. I mean, there could be a vast difference. Or they tell you to drive that far to meet them somewhere. You really need to know what dimension you're talking about. They can be very, very different. 60 miles and 60 kilometers is super duper different, right? Okay, so 1 radian and 1 degree are vastly different. 1 radian is almost, it's not quite, but it's almost 60 degrees. 1 radian each was about 57 point something degrees. So you better be sure you know what mode you're in if you're calculating something, because if your calculator's in degrees, you'll find a completely different opposite over hypotenuse than you would if you're in radians. So I want to make that stress starting out the class today, that just like 1 inch is real different from 1 centimeter. If you look at your ruler, okay? 1 degree is very different from 1 radian. I never work in degrees in calculus, by the way. Radians are that much better, okay? So you don't have to have pi in it. So if we're working in radians, why do we have pi in it so much? Because of that weird little thing that I showed you the other day that happens like in real life. So let's look at it again. And I felt like people were still really confused, so we need to look back at it. It's in both my classes, so it doesn't matter which one I go to. Let's see, topics. All right, a degree is somebody's, I don't even know how they decided on 360, and they divided the circle up into 360 degrees. So a fourth of the way through is 90. Halfway through is 180. All the way back around to 360. I guess it's sort of like wondering why somebody decided 2 plus 1 was 3, though. I mean, could have decided some other word for that. So it just is, and that's what we're doing. Well, radian measures are a lot more meaningful because they are telling you something about what's happening with your circle. Girls, before we go on, degrees and radians are dimensionless. Okay? Let's say if I have 2 tires in this room, like a car tire and a big truck 18-wheeler tire, okay? Couldn't they both turn 360 degrees? Please imagine that with me. Don't just look at your papers. If I have a small tire and a big tire, and I rotate them 360 degrees, if Nazar's got up to help me, and I rolled my tire 360 degrees, and she rolled the 18-wheeler big truck tire 360 degrees, where would she be in the room compared to me? She'd be further away. She would have even gone faster. If I said we're going to do it in a minute, then she would have covered like 20 feet in a minute, whereas I would have covered maybe 5 feet in a minute. Do y'all see what I mean? Yeah. So radians and degrees are dimensionless because they're only talking about spinning, how much it's spinning. So there are a lot of things in the world. You could be on a merry-go-round and spin 30 degrees or some form of radians, or the earth is spinning right now at a certain amount of radians per second. Let's look it up. It's called angular rotation. It's really interesting, me starting to teach you radians, and it's the only time that you've heard radians. I wish you'd heard them for a long time, just because you notice people speak in them a lot. The Earth rotates at a moderate angular velocity of 7 point whatever radians per second. So we know the Earth is rotating. And then it's also, well, it's spinning and rotating, which blows my mind that we're on this planet. Does that not blow your mind that we are not just rotating, we are spinning? Like we're rotating around, but we're also spinning around. That just absolutely blows my mind. So anyway, I don't.
Now I feel like I'm aware of it. I don't know.
Well,
yeah,
by the change of the day.
A day isn't actually
it's
a
not
day.
24 hours.
I know. It's
So
kind of
don't
weird.
those little 4 minutes add up, and then like there's just like a giant.
I guess that's what they do with leap year.
No, it's weird to think. It's not the sun that moves.
Because it feels like it,
Like,
isn't
you
it?
know how like you
We're
see,
the
like
ones
the
hundreds
sun comes up, and then like the sun goes.
Okay, so
sun goes.
girls,
down.
we got to keep moving today, okay? All right, so anyway, 1 radian is about 57 point something degrees. Degrees. You know how 1 inch is about 2.54 centimeters?
Now I do.
No. Well, 1 inch is 2 point. You've heard that somewhere before,
That must
okay?
have been 100 centimeters is a foot.
Yes.
Yeah. Really?
That doesn't have to do anything because centimeters is metric and inch doesn't have anything to do with metric. And 100 centimeters is a foot
No,
because it's cent,
12. No. You're doing, Anya, you're thinking metric system. Just a minute. There are 2.54 centimeters in 1 inch. There are 12 inches. I need to do it the other way around, or I won't get into feet for you. Okay, girls, we need to stay with me today. It's a real important day. So if I have 1 inch has 2.54 centimeters in it. And then I know that 1 foot
Oh, I meant 100
has
centimeters
12
in a
inches.
meter, not foot. I know you have to confirm. Yeah.
Okay, so that's not what you meant.
No,
So
I didn't
what
mean
were
that.
you saying?
I was saying that what she said was right. There are 100 centimeters in a meter, but then
Oh,
you have
yeah,
to
yeah,
do
yeah.
conversion to get to a foot because that's metric and foot is separate.
Exactly.
Yeah,
Yeah.
I
So
said
there
the
are
wrong
not.
word, but I know
Okay.
what I
So
was
there's
talking
not 100 centimeters in a foot.
No.
Okay. All right.
It's meters.
So anyway, back to what I was saying is 1 inch is 2.54 centimeters. Unfortunately, you know, it's kind of yucky. It'd be nice if there was a 1-to-2 ratio or 1-to-3 or something like that. 1 radian doesn't really land very nicely on our 360 degrees. Okay? So what I showed you the other day is this. What is a radian? And you may not have picked it up because I was trying to rush it and get it done. So let me say it more slowly. A radian is just the word radius. It means that we're actually talking about the radius of the circle we're working with, okay? Which when you're talking degrees, you're probably not even thinking about the radius at all. But if you talk about circles, you can see why a radian would be so incredibly meaningful. Now, I keep forgetting I'm on that. All right, so here we go. All right, so they'll draw the radius, and then they're going to wrap that radius. We don't know how big it is, do we? 3 feet, 1 foot. We don't know how big that is. It's going to wrap that radius around my circumference, around my circle. Does anybody remember how many of them we're going to get?
3.1.
All the way around?
No,
just
around
some
is-
of them.
There's
Yeah.
1 red radius,
3 rad. and
2,
then pi.
3.
And then 0.14.
Okay.
Pi rad.
Oh god.
Do anybody remember how many there are all the way around?
2 pi.
6.28.
Okay.
Or 2.8.
So, well, there, it just did it. So, anyway, if I took,
I'm so
Um,
confused as to what just happened.
Oh, because you missed this.
so this is how a radian works, everybody, not just Bren. We take the radius of a circle. So we get a piece of string. We talked about having a piece of string last week. We get a piece of string and cut it, and we say, here's our radius. I think you're familiar. I could put a pencil at the end, tie it to the end of that string, and I could draw a perfect circle with the radius going around, okay?
Yeah.
It's like then all of a sudden if I took that string up, because it's pliable, and I hold it at 0, and I start to wrap it around my
Yeah.
circle.
So it goes
This happens
roughly
every
60.
single time. It'll go around about 6 times, every single time. You could draw me a teeny tiny circle and a big huge circle, or you could go on the surface of the earth. It doesn't matter. If we took the radius of the object and went to wrap it around, every time it would go around 1, 2, 3. It doesn't quite make it, okay?
0.14.
Yes. It goes a little bit closer than that, actually. So it lands about right there. At first, it's kind of frustrating, like, oh, I wish it went 1, 2, 3. That'd be really cool, but it doesn't. It goes 1, 2, 3, and then I'm trying to like kind of do the same size. 4, 5, 6. Okay. And so what if they found this 1, 2, 3 is right there? That's 3.14. So that's why you see pi in it a lot, because if you're counting in radians, it's a really nice number. Halfway around is pi. If I wanted to talk about 3 radians, it's very inconvenient. It's 170 something degrees, a point whatever. So do y'all see why we have pi in there a lot? You don't have to. Pi actually is a decimal. What is pi? 3.14. Okay. All right. So our radians have pi in them a lot because it gives us exact places we'd like to be. Okay. Now, would it matter, like I was telling y'all the other day and kind of emphasizing with Bren today, would it matter how big that circle is? Watch this. If the circle has this black, wouldn't it still go 1,
Yeah.
2, 3, 4, 5, 6?
Yep.
Do y'all see how it goes 1, 2, 3 in the black or the red? Do y'all see what I mean?
Yes.
They're dimensionless.
And then it's gonna
Now,
be the same
here
thing
is
with
what was
whatever
really
size circle.
profound, because I know you tried to watch the video and I didn't load it. This is super cool. However, they didn't really get it. I didn't feel like it was the cha-ching thing that I was looking for the other day. So hopefully it'll be more profound today. What is the circumference of a circle? What's the formula your teachers taught you?
Pi.
Or pi d.
All right, can we do 2 pi r? Is that okay?
Yes.
All right. That's earth-shattering right there, girls. You should have gone, oh my gosh, Eureka, they were using radians. What's the circumference of a circle? Girls, isn't it this? Anya and Kate, y'all keep listening. Isn't the circumference of a circle this?
Yeah.
Around? Why didn't your teacher say
Oh my gosh.
Why didn't your teacher say 360? Okay? They went around, but they did it in radians.
2 pi and then r because the radius.
2 pi is about 6.28. Isn't it, girls? Pause and think. 3.14. All right, so let's do our radii again. So it goes 1 radius, 2 radii, called a radian, 3 radians, and we know halfway around is 3.14, or pi radians is halfway around, and if you want the whole circumference, what are you going to do with that? Double it. And your teachers taught you circumference. You were already working in radians, you just didn't know it. Guess what pi r squared, the area of the circle, is in what? It's not in degrees. So you've been using radians. Do y'all see that I can always count 6.28 times my radius and always get the circumference? Did everybody see that?
Yeah.
Let's do the little red one. All right, so 1, 2, 3.14. That's pi of those radii. That's the radius of this circle. And then I can double it to get the circumference. Your teachers knew that, but they didn't want to get into radians yet, okay? Now let's look at this. Okay, so what happens if I want to count in radians? I would do it something very convenient. Like I know halfway around, if in radians in my circle, however big my radius of my circle is pi. 3.14 of the radius of this circle. That's what a radian is, okay? Again, calculus doesn't even work in degrees. The stuff I teach them that has to do with trigonometry and calculus has to be done in radians or it won't work. That's not big news. Do you know any formulas for circumference in degrees? It only works in radians. Do y'all see what I mean? Area of a circle, you were already using only radians, so that's not that big a deal. The only shocking thing about that is why have I not done more of this before if it's that big of a deal? I don't have an answer for that, okay? It's sort of like if I could have taught you French and English all along, which I'm certainly not capable to do. If we knew that you were going to need both later, but all we did was teach you English and then throw French at you your junior year. I'm sorry, I didn't mean it that bad because you'll pick this up. People really like this stuff. Brent.
So my question is like, there's 2 pi r and then there's also pi d for circumference. Why does that work as well?
Oh, pi d is just twice the radius. It's the same formula.
But isn't it 2 pi r?
No, because
What's the diameter of a circle is twice the radius. It's the same formula. Pi d is 2 pi r. It's the exact same formula.
it's just already done before you sort of because it's like 2 meters.
All right.
Do you see what I mean? There's the diameter. So those formulas are interchangeable. These two formulas are the doesn't write well over there. Brent, that doesn't look like the light bulb's coming on for you there. Like if you go pi times the diameter, what is the diameter?
The line all the way across?
Okay, well this is the radius.
Yeah.
So what's the
it's twice
diameter?
radius?
2 pi r.
Yeah, but then why is it written 2 pi r?
Because it's
Probably just because it looks better to people.
Okay.
You can write pi 2r if you want to,
Right.
but
I mean, I
people
don't
just
but
most people usually put like the number we're used to in the front. You know, so. Okay, so if we're going to work with this, do y'all all understand now that halfway around, if I'm in radians, is pi? So what do we say, how much is this then?
pi over 2.
Pi over 2. Sorry. All right, so this up here is pi over 2. Now we're going to count each one of these. It's going to be worth 90 degrees, or in radians, it's going to be worth pi over 2. Okay? So this is 1 pi over 2. Now how many of them do I have? 2 pi over 2. 270 we call 3 pi over 2. And 2 pi. 4 pi over 2, but that makes sense based on what we learned, right? All the way around is 2 pi. Okay? Now, what if I cut those in fourth? Okay? Pi is 180 degrees. Let me write that down. We're going to be using that in a minute. Pi is 180 degrees. Oh, that's boring. Alright, so pi is 180 degrees. And if I divide pi into 4 equal parts, then how many degrees is that going to equal?
45.
Are y'all okay with that? What Kate has is 45 degrees because half of pi is 90, so a half of that would be 45. Okay? So this is 1 pi divided into 4 equal parts. Here's 1. This is 2 pi divided into 4 equal parts. What's 2 pi over 4? Isn't that just going to be pi over 2?
Yeah.
I already have that there. Are y'all okay with that?
Yeah.
So now I'm at 3 pi over 4. 4 pi over 4, are we okay? 4 pi over 4 is pi. 5 pi over 4. 6 pi over 4, is that okay? 6 over 4 is 3 over 2.
Yeah.
7 pi over 4. And now I've counted 1, 2, 3, 4, 5, 6, 7, 8 pi over 4 is 2 pi.
If you're just trying to show that, like, we're at like 270 though, couldn't we just do? No, I guess not.
Okay, jump back in if you think of something else you want to say. Girls, this could just be a decimal. Couldn't I type 7 times pi divided by 4 into my calculator? And it would just be a decimal. Would somebody do that real quickly? 7 pi over 4. Does anybody have a calculator out? We can put it in our computer. 7 pi over 4. 7 times pi divided by 4. You have a pi button on your calculator.
So then, it's 5.497778.
All right, hang on just a minute. I'll be back to you. All right, girls, that makes perfect sense. 5.49 something something radians. Watch me count with my radians in yellow. Remember how it went about right here? 1, 2, 3, 4, 5, 6. Do you see how 7 pi over 4 should be about 5.5 of those? I don't know if y'all see what I mean.
Yeah.
Okay, let me hit the undo button because I don't want those on there.
It looks right.
Okay, so what we're doing, the reason your radians so often have pi in it is that's where your 45 and 30 and 60, 90 triangles land. All right, so now let's go blue. All right, y'all ready, girls? And you could just be watching, okay? We've got the workaround with our 1, 2, 3 chart, so we don't have to do the big unit circle that I think I've shown you that other people have or you have seen, okay? All right, now kind of try to ignore the black, okay? So you're good. All right, so if this is pi and I divide it up into 6 equal parts, how big is each of these blue ones? Please focus on the blue. If I take pi and divide it into 6 equal parts, if I could draw over there. If you take 180 and divide it into 6 equal parts, how big is each part? 30 degrees. All right, so this is 30 degrees, but it's also pi divided into how many parts? 6. So this is 1 pi over 6. That's 30 degrees. The next one is 2 pi over 6. It jumps over 45. So this is a slice of pi, like Thanksgiving, pi over 6. And you want another one that size. That's 2 pi over 6. What's 2 pi over 6? 2 pi over 6. Pi over 3. All right, what's my next slice of pi? How many do I have now? 3 pi's over 6, which is pi over 2. Half pi, pi over 2. Now I'm at 4 pi over 6. That's 2 pi over 3. 5 pi over 6. 6 pi over 6. Do y'all see I'm now at 6 pi over 6's?
Yeah.
Which is pi. I'll keep going. This one's 7 pi over 6. 8 pi over 6. I'm not going to write down 8 pi over 6. 8 pi over 6.
Let's just do
8 pi over 4 pi over 3. 4 pi over 3. All right, so now I was at 8. This is 9 pi over 6, which is 3 pi over 2. The next one's 10 pi over 6, which is 5 pi over 3. Where was I? 11 pi over 6. Until I've eaten the whole thing, and I'm now at 12 pi over 6, which is 2 pi, okay? All right, now that's a big mess, but I want y'all to see something in this yellow and red and green maybe. All right, in yellow, look at the pi over 3's. Look at the bow tie, butterfly, with my pi over 3's. Did y'all see I just connected all my pi over 3s?
Yeah.
Those are all my 60-degree reference angles. Do y'all see those bigger ones? 60-degree reference angles.
So just go 1, 2, 4, 5.
Hang on just a minute. Do y'all see these 60-degree reference angles right here?
Yeah.
Okay, that's pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3, okay? But I'll show you ways to remember them in just a minute, all right? Everything that get reduced with a 3 is a 60-degree angle. That should make sense to you because pi is 180 degrees, right? So if I take pi and divide it into 3 equal parts, that should equal 180 degrees divided into 3 equal parts. Do y'all see that should equal 60-degree angles?
Yeah.
Okay. All right. Also, I'll show you that in just a minute. Now let's get like a really bright color. Let's get white. All right. Let's look at our pi over 4s. Bow tie. Now try to rule out the white, and you're just looking at the pi over 4s. I just went. I hit everything that was a pi over 4. Kate's already said it today. Those are all of my 45-degree reference angles. So radians are going to be easier to work with, even though if you don't believe me right now. If I see something over 3, I know automatically I have a 60-degree reference angle. If I see something over 4, I know automatically I have a 45-degree reference angle. What if you take 180 and divide it into 6 equal parts? You should see 30-degree reference angle. So let's look at that in neon green. Okay? So here's my pi over 6s. Do y'all see that bow tie? Little skinny 50s bow tie, okay? Do y'all see those all landed at these pi over 6s?
Yeah.
Okay.
And that's always 30 degrees.
Anything pi over 6 is 30 degrees. So watch this. Suppose I'm going to want you not to convert later. I'm going to want you to understand radians. It's sort of like if you're fluent in Spanish, then you're not needing a Spanish-English dictionary. Okay, I don't need somebody to translate for me if I'm fluent in Spanish, which I'm not. Okay, but if I was, I could talk to you in English and I could turn and talk to you in Spanish. When Miss Badar was still in the Math Center, y'all might remember when Denise, they live in Turkey now, but you know, she and Atir Arkan, Miss Arkan would go back and forth in English and Turkish, and we didn't know what was happening. Every now and then you'd hear an English word, but they knew what was happening. They could just do it fluently. I'm sure some of you are fluent in other languages. I want you to eventually be fluent in radians. But until that time, there's 2 things you can do, and you can pick and choose, okay? You can convert it, which I don't know what you did on homework. You probably had to really think about converting something into degrees. Girls, eventually I don't want you converting in degrees, okay? I want you to be able to think in radians. But you're really good at trig and radians right now. You're really good at trig and degrees. To convert to degrees, how do I convert? Hang on, I'll get you just a second, Mia. If I want to convert 3 feet to inches, don't I go 12 inches is exactly 1 foot?
Yes.
Okay, so I can say 180 degrees is exactly,
1 radian.
no, 1 radians, pi radians.
Oh,
3
that's what
point.
I did.
You may have looked that up,
That's what I
or,
did for
wow,
homework.
good. So did you look it up, or you thought about it,
I
or?
was just like,
I just looked at the unit.
That cancels, or you could just look at the circle. We're going to find a better way today. If I keep reducing, 4 goes into 180. That's really loud. 45 times. And then 45 times 5 is 225 degrees, which you probably recognize from your old stuff. All right, now if I scroll back up here, look at where 5 pi over 4 is. I think it's pretty convincing in this big mess of the unit circle that I don't use. I agree that would be 225 degrees. It's 45 degrees away from 180. Do you see how you start to think in both languages, okay? Another alternative, I've had a student that showed me this. They don't do that. They just go, oh, well, I know that I can take out pi and put in 180 degrees. Like that's the technical conversion.
That's what I did.
But every pi, if you want to convert, you could just convert pi to 180, and that'll give you the right thing, okay? If you have degrees, though, girls, if you have degrees, you do have to multiply it by pi over 180. We're about to write on your memo page after I take Mia's question, so.
Oh, that was just...
Okay, so get out your memo page and let's write something on it. Brent?
So like, never mind, I'm sure you're gonna get to it.
Probably so. If you,
Wait, I have a question.
all right.
When you write like costan in front of the
like the trigonomic value, does that like help make it a negative radian?
Hang on, I'm gonna work a whole bunch of problems, so let's get this on your memo page, okay? I'm gonna work a bunch of problems and probably answer your question more organically. So in a box, it doesn't really have a name, okay? But if you wanna go 2 degrees, if you wanna convert 2 degrees, you multiply by 180 over pi. I'm sorry, wait and let me write it and try to get it on this silly board. Alright, so we'll call this conversions from radians to degrees and degrees to radians to go back and forth, which you actually won't do a whole lot. You'll get fluent in both. If you want to convert from radians to degrees, degrees has to be on the top, and you multiply by 180 over pi. If you want to convert to radians, pi needs to be on the top. Okay? That'll allow you to convert back and forth from one to the other. Those are what we call our unit conversions. Let's try to refrain from asking questions just for a little while after I answer Anya's, okay? Because if I can crank out some problems, I promise you'll get this.
It's about the test, but I don't know if you can answer yet. Are we gonna have to draw out a unit circle? On
No,
the test? Oh,
I hate that thing.
okay.
No.
You just like
What about like a IOU chart or a 1, 2, 3 chart?
Yeah, you probably will want to, unless it's just
That's
emblazoned
like
in your
personal
head.
use.
Yeah.
The only thing I sometimes mess up is I do STC instead of STT.
Oh,
And I
don't do
realized
that.
you
Think
just
of
use
a-
so that
Think of, say like,
Yeah.
think of a, come up with a way to make that
Isn't
happen.
it so that
All right,
how
now
she did
while-
the radians?
While you have your memo page out, you have that little sine, cosine, tangent chart,
Where's this theta you drove?
and it's time to put our radians in it. Girls, please listen. You know how it goes 3,
This is
4.
for the IOU chart, right? Or no, 1, 2, 3 chart.
It'd just be really awesome if y'all listen. I'm gonna tell you, okay? That chart, your 1, 2, 3 chart, okay? Out to the side of 30 degrees, you're now gonna put anything pi over 6. If it lands at one of the slices of pi over 6, it's a 30-degree reference angle. 45s are pi over 4, and 60s is pi over 3. There's a few people that don't understand what they're doing sometimes when I teach this, and they get confused. They think the 30s should be pi over 3s, and the 60s should be pi over 6s. Do you understand that doesn't make sense though?
Yeah.
If I divide pi up into more pieces, won't they be smaller? Okay. So always start your chart, I'd suggest, still with 3, 4, 5, 6, then you can go back and fill in this part. It sort of goes like, watch this, see, it sort of goes like that. And the fours match up, okay? But go in and start with how you learned 3, 4, 5, 6, then you can put in the others and make sure you're careful. You understand, girls, pi, that's 180 over 6. Do you see how it can match 30 if you're thinking about it on the test? So y'all are filling this in to your 1, 2, 3 chart right here. Has everybody written that on their 1, 2, 3 chart now? It's full.
Yes. Yeah.
Okay, now go to your IOU chart, and you have sine, cosine, tangent. You have 0 in your degrees, 90, 180, 270. All right, next to that would be in your radian column would be 0 radians. Half of pi is 90. 3 pi over 2. I'm sorry, I just did that wrong. What's 180?
Pi.
Pi, thanks Kate. Pi, and then 3 pi over 2. So you're writing, fill in that in your 0, 1, 0 IOU chart. Okay. And we're going to spend the last 10 minutes on the worksheets I just handed out. So please do this. I'll try to remember to even put it in assignment. If after today you still have questions on homework you did for today, we need to go over that. We'll have time to go over that on Wednesday. Okay? So I hope I remember to put in assignments. But if I forget, part of your homework is also go back and highlight things you still have questions about. Probably just on last night's homework. Now let's look at your sheets. and I'll show you how to do this. It's not how I learned to do it, but I think this is a better way. I'm always willing to try something better, okay? We'll move these cute girls out of the way so that I have plenty of room to write. Well, they just popped back in. Okay, goodbye. Oh no, I'll just delete it. It's kind of creepy to have just her butt sitting in there. Okay, so now on worksheet 3 on trig values, you've already done worksheet 1. Ironically, you did worksheet 1.5 and worksheet 2. I wasn't ready for worksheet 2 for y'all, so we did 1.5. All right, cosine of 5 pi over 4. I don't actually think that you'll have time on this test to stop and convert all your radians to degrees. Okay, these will be without a calculator, by the way. And so I'm not a fan of converting it to degrees. Pretty soon you'll just start to be fluent in radians. This is what I do. It's a mix of what some of my students have said that they did. I learned on the unit circle. And so you'd have to look around your circle for 5 pi over 4 and read all that stuff if you've seen the big, huge, ugly unit circle. I'm not a fan of the unit circle for a few reasons, because their mind gets stuck that the radius has to be 1, which it doesn't. Another reason is I might ask you negative 3 pi over 4, and you're rotating the other way, and that's not anywhere in your circle. So our way is going to work all the time. All right, I had a student that named Wesley Ingram. He said he did this way. First of all, I already got the number, okay? Did y'all see that pi over 4? That's a 45-degree angle. So look, I've given you time to look at your memo page if you need to, or some of you don't need to look anymore. What's the cosine of a 45-degree angle?
Root 2 over 2.
Root 2 over 2. So I just have to decide what quadrant this is in. Do y'all all understand that just landed at one of these? Sorry, it's so off center over there. Do y'all see it's one of those pi over 4s? Do y'all see in your chart how pi over 4 is next to 45 degrees? All right, so I had all sorts of ways to tell my students.
Oh my gosh, and then it's one of the 6.
Girls, hang on. This method will always work, and it works really well. Get the closest multiple of 4 that you can to the number you're looking at. The rule is you can go 1 over or 1 under. Like 4 won't go into 5. So the closest multiple of 4 I can think of is 4 pi over 4. Believe it or not, you'll get to where you can do this in your head. All right, you'll just see it. Where is 4 pi over 4? Isn't it pi? So where's 5 pi over 4? It went past it into the third quadrant where cosine is negative. Okay? This Wesley Ingram method, the guy that's one of my students, has said, wait, let me show you how I remember it. And at first I wasn't even listening to him, and it sounded pretty good. Kind of like the Robert Harris 1, 2, 3 chart. But you know how if I say 120, you automatically think of 180 and see how far you are from it? Or if I say 300, you think of 360? He has us thinking of pi and 2 pi. We're still doing the butterfly in radians, okay? All right, so what's number 2? Number 2 is the tangent of 11 pi over 6. What reference angle do I have automatically? 30-degree reference angle. And it's square root of 3 over 3. Now I just have to decide on my all students take calculus. 6 won't go into 11. What's the closest multiple of 6 you can get to 11? 12. Good. What's 12 pi over 6? 2 pi, which is over here, right?
Yeah.
Did it make it there?
No.
So it's in the fourth quadrant. All students take calculus. So what is tangent in the fourth quadrant? Negative. And go slowly through it. When I give you your homework, just go slowly through it. You'll get better at it. Let's keep going. We're going to be awesome at tan of negative 5 pi over 4. Is that your next one?
Yeah.
Whereas we might be a little better at this because negative 5 pi over 4 is not on their unit circle. They'd have to figure out like what it's coterminal with. Okay? 4 won't go into 5. What's the closest thing it'll go into?
4. Right?
4 won't go into 6. So think of multiples of 4. Oh, okay. So 8, but we're too far away from it. You can only be 1 away. So you're going to stick to 4 pi over 4, which goes like this, is pi. But girls, it's negative. So far I've gone negative 4 pi over 4, and I got to get to negative 5 pi over 4. What quadrant is that in? Second quadrant, okay? So it's negative because somebody's already gone to all students. What's my reference angle? You can say it in degrees if you like, pi over 4s. 45 degrees, tangents of 45 degrees are 1. So I believe we've decided on -1. It's a 45-degree reference angle in the second quadrant, all students. This is not negative because that is negative. That is not the case. Okay, girls?
Oh.
This is just a rotation. You're going around. You could land anywhere. Anya, you sure you have a question?
Yeah.
Go ahead.
So let's say it landed in the quadrant where tan was positive.
Then you use positive. Let's keep going.
Can you cancel out negatives or is that not allowed?
Why would you cancel out
Actually,
negative?
never mind. It was a dumb question. I understand.
It's not a dumb question. Are you okay?
Yeah, I got it.
Okay. This is just the positive and negative spin does not affect the positive or negative answer.
Okay.
Okay. What's the closest multiple of 6? You can get to 7.
6.
6 pi over 6. All right. Where is 6 pi over 6? It's at pi. Did I make it there?
Yeah, use it.
And I even went past it into the third quadrant at a what degree angle? Pi over 6s or
60.
what? Pi over 6s?
60.
Pi over 6s?
30.
30s?
So 1, 2, 10.
So you have 1/2.
Yeah.
Okay.
But then you'd add the 30 degrees to the.
Oh no, what's happened is we've gone to 6 pi over 6, but
Yeah.
we were trying to get to 7 pi over 6, so we landed right there at a 30-degree reference angle.
Oh.
So sine of 30 is 1/2. All students take, what is sine? Negative? Okay. Girls, if you stopped and converted that to degrees, you'd get 210, okay?
Oh, this is secant.
Oh, I'm so
Yeah.
sorry. Oh, that's why you said 2.
Oh, and it's
Or I
3.
guess maybe.
I said
Yeah, 2 because it's the opposite.
See, oh wait, I skipped the whole problem. I'm on number 5, I'm sorry. Skip a problem, I just did number 5. No, I didn't. Just forget anything I just said, other than it was a good problem, but it wasn't on your sheet. I can't imagine I could have read it that bad. Apparently, I really wanted to do that number. All right, so let's backtrack. Number 4, secant of 7 pi over 3. Don't feel bad if you have to take a little time doing this, because you got to find where it is, and you've got to find the cosine of it, and you've got to get the sine of it, and you've got to remember to flip it over. Okay? So you can draw yourself a little picture. All right, 3 goes into 7. What's the closest multiple? 6. So my brain's thinking 6 pi over 3 to get me started, which is 2 pi. So I go right here, and then what do I do? A little bit more into a what degree reference angle? Pi over 3s.
60.
60. Okay? You could write yourself some little notes. Cosine of a 60-degree angle is 1/2. All students, so it's positive. So what's the last thing I need to do to get secant?
-2.
Whoa, 2.
2.
Oh, 2,
Everything's-
because it's in all students take calculus.
Yeah.
So it's off. So it's just-
Okay, is this 17 pi over 6, number
Yeah.
5?
Wait, why am I thinking like I see like the 6, but then I want to go back instead of keep going. So then I put like it in like the 4th quadrant rather than like the 1st quadrant.
It all depends. Let's do this one, okay? Bren, what's the closest multiple of 6 you can get to 17?
18.
18. Where's 18 pi over 6?
It's at like
Where do you think 3 pi is? It's all the odd pi's are over here. So you went like this, okay?
Yeah.
Not that you have to draw it, you just have to know you're over there. Did you make it there?
no.
No, so you're up here. Do you see if that had been 19?
Yeah.
That's how you know, okay? All students, the answer's going to be positive. And pi over 6s are what degree reference angle?
30.
30. So this is 1/2. Brent, did I kind of answer your question?
Thank you.
All right, so let's do some more. I think worksheet 4 and worksheet 3 are a lot alike. Let's do cotangent pi. Now, we really haven't done one of those that lands just right on what we call a quadrantal angle. But pi, you're just going to look at your IOU chart. Okay, so be careful. What's the tangent of pi?
Oh, it's -1.
No, tan of pi. I'm sorry, what are you looking up in your
Tan
chart?
of 180.
Tan of 180 is at pi?
Zero.
A 0, so you're right, Alina. The reciprocal of 0 is undefined. What's the reciprocal of undefined is 0, okay? All right, I'll
it's
explain that.
undefined.
The answer to this one is undefined. Okay, most of the things, not just Kate, girls, y'all look at this. Remember back in our first unit, if we had an asymptote and it was undefined, it's usually undefined because you've gone off to infinity. Like that boggles our minds. And that's what tangent's actually doing at pi. And when I teach you to graph it later, it's going off to infinity.
I just get confused with the reciprocal.
And what's the
of zero.
reciprocal, what's the opposite of having everything?
Having nothing.
Right. And if you have nothing, what's its reciprocal?
Having everything.
Which is undefined. Does that help?
Yes.
Okay, I think we're probably ready to go, and it seems like y'all have gotten it, so keep kind of lipping along through. Why don't, I'm not going to give you Delta Math, I'll give you something to practice in the next class, and we can just interact together, and I'll give you a list of topics. So you're finishing worksheet 3 and 4. And I'll also attach them to the assignment because Dakota will need them, okay? So if you lose yours or don't have yours with you,
So Miss Lazari,
try to think in radians, try not to convert.
so Miss Lazari, when's our next test?
Friday.
Friday. And if
I'm
you,
not gonna be here, so either
Okay.
on Thursday.